Welcome to this tutorial on how to solve trigonometrical identities, which is questions that you might find in your further pure 1 maths paper. Now here's a question that is very typical of the ones that you might find in your exam, which many of you I'm sure are sitting at the end of this year. Now I'm just going to go through a typical question and explain how to solve each part of it. Now hopefully by doing this you will understand the reasoning behind the way it works and therefore be able to do many more questions just like it. Right then, we'll start with part A as it's at the beginning. It is given that x satisfies the equation 2 cos squared x equals 2 plus sine x. Part A. Use appropriate trigonometrical identity to show that 2 sine squared x plus sine x equals 0. Now, in order to do this, we need to make use of one really key piece of information, and without doing this, you basically cannot solve the question. That is, sine squared theta plus cos squared theta equals 1. Right then, as you can see on this piece of paper, or hopefully you can see, I have written out all the different ways this can be put. So I've got sine squared theta plus cos squared theta equals 1, I've got sine theta equals 1 minus cos squared theta, and I've got cos squared theta equals 1 minus sine squared theta. Now for this one, we need to make use of the cos squared theta equals 1 minus sine squared theta, because we're going to substitute that into the equation up there. So to start with, we have got 2 cos squared x and theta are interchangeable in this, so don't worry about it, equals 2 plus sine x. Now, I've just rewritten the question, hopefully slightly bigger than before so you can read it a bit better. Now what I'm going to do is I'm going to do 2, 1 minus sine squared theta equals 2 plus sine x, or sine theta. We'll just keep sine theta because I've written it first time. Now expanding this out should give you 2 minus 2 sine squared theta equals 2 plus sine theta. Now if you simplify this, you will be able to cancel out the 2's and you should end up with 2 sine squared theta equals, 2 sine squared theta plus sine theta equals 0. Now then, that is how you solve the first part. As you can see, by substituting 1 minus sine squared theta, we have managed to end up with the form that is used in the question. Now part B is slightly more difficult. Part B reads, solve the quadratic equation and hence find the general solution in radians of the equation 2 cos squared x equals 2 plus sine x. Now we've already rearranged the equation into 2 sine squared theta plus sine theta equals 0. Now what we've got to do is effectively work out the factors of it. Now what I tend to do is I tend to substitute sine theta in for another letter, so I'm just going to pick u because u's nice and easy. Now the thing is you can just factorise it using sine squared theta and sine theta. That's not a problem either way, it doesn't really make a difference. I just tend to use u because it makes it look more like a quadratic equation to me, and so that's kind of how my brain works. So what we end up with then is we end up with 2u squared plus u equals 0. Now obviously if you want to factorise this, you can take out a factor of u, so it's u 2u plus 1 equals 0. Now from this we know that u, sorry if I've missed the last line of working off there, you should be able to see it a bit better. Right, what you should end up with is u equals 0, or that's one of the factors. You also should end up with 2u plus 1 equals 0. Therefore we know that u equals minus 0.5. Now in order to solve this in terms of radians, first of all we need to do an inverse sine of both answers. So we're going to do sine minus 1 0, which equals 0, as you'd probably expect. And then we've got sine minus 1 minus 0.5, which equals minus 30 degrees. Now minus 30 degrees is not an acceptable answer in this question because it says hence find the general solution in radians. Now radians are denoted by the letter pi, and the letter pi, or the Greek letter pi should I say, is equivalent to 180 degrees. Now in order to write minus 30 in terms of radians, we need to work out for starters what 30 degrees is in radians. Now 30 degrees in radians is equivalent to pi over 6, because pi is 180. 180 divided by 6 is 30 degrees. So you can probably see where we're going with this. For example, if you wanted 90 degrees, you'd do pi over 2. If you wanted 45 degrees, you'd do pi over 4. So we can write minus 30 is equivalent to minus pi over 6. If we've got, we'll come back to the 0 later. Now the general formula, if you're using sine, is effectively 2n pi, which is 2 times your number, or 2 times the factor, times pi, which is obviously 180 in this case, plus a. We're just going to use a as your angle. Now, in order to do the general formula for this, what we're going to do first is we're going to start with the 0. Now, the general formula for this is just n pi. Sorry, n pi. Now, the reason why it's n pi is because it's 2 times 0 times pi. Now, therefore, we can just cancel out the 2 effectively, and it's just n pi. And this is basically what we do. This is the general formula for when sine minus 1 is 0. When sine minus 1 is 0.5, you know that it's minus 30 degrees, which is we know is equivalent to minus pi over 6. Therefore, we write it as 2n pi, again, because that's keeping with the general formula, minus pi over 6. And that should be able to give you the answer for any case. Right then, I'll just run through the first 2 steps again. Using the trigonometrical identity sine squared theta plus cos squared theta equals 1, and then rearranging this so cos squared theta equals 1 minus sine squared theta, we have substituted in 1 minus sine squared theta into 2 cos squared theta equals 2 plus sine theta. Now, having cancelled this, we've ended up with 2 sine squared theta plus sine theta equals 0. I've therefore done sine theta equals u for the next part B, and then we factorised it, so we found u equals 0 and u equals minus 0.5. We've inverse sine of these numbers to end up with our angles, and then we've converted the minus 30 degrees, which is the angle we do have, into radians, which, as we know, pi is 180, is minus 180 over 6. And then we have added that into our general formula to find the general formula of the angles. Now, all we have to do now is do part C. Part C is hence find the general solution in radians of the equation 2 cos squared theta equals, 2 cos squared 3 theta, that's the important bit, equals 2 plus sine 3 theta. Now then, for that, we're going to move to the top of the page again, because I've got room, and we're going to do things, this might sound really difficult. I mean, you just have a look at it and 3 theta, you're like, oh no, how do I do this? It's easier than it looks. You know the general formula already equals, where is it, n pi, or pi n, doesn't matter which way you write it, or you know it equals 2n pi minus pi over 6. Now all we've got to do is, because it's 3 theta, we divide the whole thing by 3. If it was 4 theta, divide the whole thing by 4. I think you get the picture. So, for starters, we'll take the one that is just n pi. Well, we need to divide that by 3. So therefore the new general formula for 2 cos squared 3 theta plus 2 sine plus 2 plus sine 3 theta is equivalent to n theta over 3. Simple enough. Now then, we'll use the other one, which is 2n pi minus pi over 6. Again, we divide this by 3, which gives us an answer of 2n pi over 3 minus pi over 18, because 6 divided, well, in this case, because it's a denominator, we times it by 3. Now that is how you find the general formula if you've got a value, if you've got a number in front of the theta. Now hopefully this should explain how to do trigonometrical identities. Now in this question we've only used sine squared theta plus cos squared theta equals 1. There is another trigonometrical identity which is tan theta equals sine theta over cos theta, which I'm sure you will use in the very near future. Thank you for listening.